Today, we'll be talking about tilted coordinate systems. So, how do you solve for these? Well, tilted coordinate systems, if you solve them in the traditional sense, where you treat the straight horizontal as the x-axis and the straight vertical as the y-axis, it won't work. You need to tilt the coordinate system somehow, where the y-axis is like so, and the x-axis is like so. So let's go ahead and try to solve for this one first. Let's draw the free body diagram for this 50 kilogram inclined on an inclined plane at an angle of 30 degrees, and try to solve for the normal force and the acceleration. So let's draw the dot for the free body diagram. And I'll draw a dot. This is the weight force. Weight force is straight down, and the normal force is perpendicular to the plane. So if the normal force was perpendicular to the plane, it'd be going in this sort of direction here, shown by my free body diagram. Now, what if I treated this problem like the traditional free body diagrams that you do? Like this, right here. What if I use the x and y coordinates as the horizontal and the straight vertical? Well, as you try to solve for the weight force, so weight is equal to mg. We have 50 kilograms of the box times 9.8 meters per second is gravity. It's equal to 490 newtons. So the weight force is 490 newtons. As you solve for the weight force, what you realize is that the normal force has two components, and you can't solve for those two components. It is impossible to solve for them. So what can you do? Well, you can actually rotate your coordinate system like so to this new coordinate system, where the x-axis becomes parallel to the plane. So this x-axis is parallel to the plane, or parallel to the ground at your surface, and the y-axis is going in the same direction as your normal vector. It's usually called y prime and x prime. So your normal force is going to be parallel with your y-axis, and your new x-axis is going to be parallel with the ground. And this makes sense because axes are 90 degrees from each other, and your normal force is 90 degrees from the ground. So what did I do here? Well, all I did was actually just rotate. I rotated my coordinate system like so, in the clockwise direction. And when you do that, you actually can create an angle between the weight force and the new y prime axis of the angle of the incline. And this is usually going to be the case if you're rotating in the clockwise direction. So if your plane is in this direction, not in this direction, then your weight force will be the angle of your incline. And actually in the other direction, if it was like so, this is 40 degrees. Oh, yeah. Your weight force would make the same angle at the y prime axis. So usually your weight force is going to make the same angle as the angle of incline. And if you logically think about this, then it would make sense because of this rotation aspect of your new axes. So if you solve for it like this, what happens? Well, your weight force is 490 newtons, and your normal force is unknown still. But what you can actually do is solve for the cosine, or the y component of your weight force here, by multiplying 490 by the cosine of 30. So if you multiply your weight force by the cosine of 30, you will get the adjacent side of this angle here. And this adjacent side is your new, I guess, f net of y prime. I'll be more specific here. So if you do calculate 490 by the cosine of 30, you get, where's my problem? You get 424.35 newtons. But this is negative because it is going in the negative y direction in our new tilted coordinate system. Therefore, our normal force is the only other y prime force. So we add that into our net equation. But since this box isn't falling through the ground or accelerating upwards, all of this is equal to 0. Therefore, your normal force is equal to 424.35 newtons. Now, we can actually solve for the acceleration. So, the acceleration of this box is dependent on the x direction. So why is it dependent on the x direction? Well, because this box isn't accelerating through the ground or up into the sky. So the only other non-solved force, so this force was 424.35 newtons for the weight force on this side of the weight force. The only unsolved part is this guy right here, and this guy is just solved by 490 times the sine of 30. The sine of 30 will just give you the, I guess, the quote-unquote x prime component of your weight force. So if you type down 490 times the sine of 30, you get 245 newtons. So this is 245 newtons on this component of your weight force. And since this is the only weight force going in the x prime directions, we can calculate the acceleration by dividing per the Newton's second law of motion. We can divide force by mass to get acceleration. So you divide the force by mass. So the force was 245 newtons in the positive x prime direction by 50 kilograms, which is the mass of the block. You get an acceleration of 4.9 meters per second squared. And don't forget, I need to write the acceleration vector in my free body diagram. And this acceleration is going in this direction, so I'll draw an arrow that's going in that general direction, in the x prime direction. So in this problem again, we're going to use a tilted coordinate system. So we'll represent the box as a dot in the free body diagram. But this time we have a force that's going straight to the right at 20 newtons. So it adds just a little bit of complexity to what we're doing. So let's draw the first part. Almost always there's going to be a weight force unless if you're out in the middle of space. And this weight force is W. Okay, we have a force straight to the right at 20 newtons. Let's just call it F. We also have our normal force. Normal force is perpendicular to the plane, so it's about going this direction. And that is all the forces that are acting on this box. So take a guess. What will be our tilted coordinate system in this case? So if you guess like so, you are right. Because a tilted coordinate system, usually you want the normal force to be in the same direction as your y-axis. So this normal force is going in the same direction as the y prime axis, in this case y prime, and this is x prime. And we're slanted at a 45-degree angle. This time it's slanted the other direction. Remember what I said, usually the angle between the negative y-axis and your weight force is the angle of the incline. And if you just work out the logic inside of your head by just rotating the coordinate system, you'll see that this makes sense. So we also have the force going straight to the right. Well, since the weight force and this force are perpendicular, weight force is going straight down and this force is going straight to the right. They make a 90-degree angle. That also means that this makes a 90-degree angle. Therefore, if this makes a 90-degree angle, that means it's a 45-degree angle between the negative y-axis and the 20 newtons force as well. And our normal force is just along our y prime axis. So we have everything we need. Set up this free body diagram, and we can solve for this now. So the weight force is equal to mass times gravity. And if you just multiply if you just multiply 10 kilograms times 9.8 meters per second squared, you get 98 newtons. So the weight force is 98 newtons. This force is already given, it's 20 newtons, but the normal force is completely unknown. So let's write down a net force equation in the y prime direction. And we could solve for the y components of these forces, or y prime components if I'm more specific. So if I multiply 20 by the cosine, so I can get this side right here. Okay, yellow is a very, very bad color to put over that. Let's use blue. I can get this side right here. These are triangles. So I multiply 20 by the cosine of 45. I can get the y prime component of this 20 newtons force. And since this is going in the negative direction, this will be negative. Actually, I need more space for this. Let's put it down here. And also for the weight force, I can solve for the negative y prime component by multiplying 98 by the cosine of 45. And we also have our normal force in the y direction, in the y prime direction. And those are all the y component forces that are going on here. So we can just solve for the normal force here because the y direction, or the net acceleration is 0 in the y prime direction. Therefore, all these equal to 0. So if you do a little bit of algebra, in the end, you get that the normal force is equal to 83.44 newtons. So the normal force here, if I were to just look at this equation, sets the normal force equal to 83.44 newtons in this direction here. So this is 83.44 newtons. Now, what do we do next? We just need to solve for the acceleration. So we need to look for the net force in the the x prime direction. So let's set up that. So F net x prime. And the only two x forces going on are this one and this one. Let's use a different color. This one and this component. So the opposite of this 45-degree angle is this side right here, which is the x prime components of these weight force and this 20 newton force. So if you were to solve for these two components, you would get, so let's multiply 98 by the sine of 45 to get the opposite side. And since this is going in the negative direction, the negative x prime direction, this would be minus. Make some space for the minus. This would be minus, and the other side is positive, so we put plus, and this is simply just 20 times the sine of 45. And this is it all. If we were to solve for both of these, all you get is a force of negative 55.15 newtons, which means that the total net force is going in this direction here, the negative x prime direction. So all I have to do, F equals ma, divide force by mass, and you get acceleration. So if I write down, let's just write down the magnitude of the force. 55.15 newtons divided by the mass is 10 kilograms. You get 5.515 meters per second squared. And this is the acceleration in this direction. So if I write the acceleration vector in this, you get arrow that's pointing down 45-degree angle. So for this problem, you have 300 newtons and 100 newtons as additional forces that are making this problem a little more complicated. We also have an incline of 15 degrees. Keep in mind this 300 newtons is going in the same direction, or is parallel as this plane right here. And the 100 newtons is going straight to the right. So let's draw the free body diagram first. So the free body diagram has our weight force. I will never forget that guy. We have the 100 newtons going straight to the right. And I'll just write 100 newtons for that. And we have our 300 newtons going parallel to the x-axis, to the plane, sorry. And one last force, we have the normal force, of course. Prevents the block from falling through the floor. So this is our free body diagram. This is approximately what it is. But, of course, try this out. Try to solve the entire problem, and then, or try to guess what the inclined plane looks like. So what we'll treat as the x and y axes, or x prime, is this right here. Since the 300 newtons is parallel to the plane, or the surface, this guy will be the x prime axis. And the normal force is always in the direction of the y prime axis. So this is y prime, this is x prime. I'll draw the arrows. And let's solve for the angles between everything. So the angle between the negative y prime axis and the weight force is usually the angle of the incline. It's a little shortcut that you can use. We also don't know what this force is, this angle between the x prime axis. Well, if you use just a little bit of logic, you'll be able to conclude that this right here is 15 degrees. And the reason why is because since this goes straight to the right, this is the old x-axis, but the plane is kind of going in the plane was rotated 15 degrees. If the plane was rotating 15 degrees in this direction, it was also rotating 15 degrees in this direction. So if the plane was rotated 15 degrees in this direction, so this is 15 degrees, and this was the old y-axis, the plane was also rotated 15 degrees in this direction. So the old y-axis here. Therefore, the angle between the new x prime axis and your 100 newtons additional force is 15 degrees as well. So let's go ahead and solve for the rest of this problem. We have our weight force, so weight is equal to mass times gravity. 25 kilos times gravity is 9.8 meters per second squared. You get 245 newtons. So 25, let me check that on my calculator. I kind of just did that really quickly in my head. Yeah, 245. Okay, so the weight force is 245 newtons here. And what do we do next? Well, all we got to do is write our F net of y prime equation. And that's because we just need to solve for the normal force right here, as the prompt states. So since the normal force is going the y prime direction, what other better thing to do than solve for the net y prime force? So let's solve for all the components in the y prime direction. Well, this guy has a y prime component right over here. The weight force has a component right over here in the y prime direction. But the 300 newtons is going directly on the x prime directions. And this right here is also going in the x prime direction. So we have the normal force, the y prime component of the 100 newtons, and the y prime component of the 245 newtons. So how do you solve for all these? Well, the weight force is 245 newtons. And if you want to solve for this component of this weight force, you multiply it by the cosine of 30 to get the adjacent side. And this is negative since it's going in the negative y prime direction. We also have our y prime component of our 100 newtons. And if you multiply 100 newtons by the sine of 15, you also get the opposite side component. And we also just have our normal force. So if you solve for everything, you should get 0 because this box, again, is not accelerating upward or downward into the plane. So in the end, you get a normal force of 210.78 newtons. So this guy is our normal force. Okay, how about our acceleration? Well, the acceleration just worries about the net y prime forces. The net y, x prime, sorry, not y prime. The net x prime forces. So what are the x prime components? We have this guy right here. Let's use a different color so I can clarify what I'm talking about. We have this guy right here, which is the y. I keep saying y. Ugh. The x prime component of our 100 newtons. We also have this guy down here, which is the x prime component of our weight force. And we have this 300 newtons that is going directly in the x prime direction. So we have 1, 2, and 3 to account for. Let's solve for all those 3. Well, this 245 times the sine of 15 gets the x component right here of the weight force. The 100 newtons times the cosine of 15 gets the adjacent part, and I put this, technically these are all positive because these are going the positive x prime direction. Did I already say that? Yeah, it doesn't matter. And we also have the 300 newtons going in this direction here, which is negative. This is the positive x prime direction. This is the negative x prime direction. So we do minus 300. So our total net force, put these all into a calculator, is negative 100 approximately. It was like 139.99. So it was like negative 139.99, like 5 or something. I don't know. It's just negative 140 newtons. And dividing force by mass, you get acceleration. So I just divided 140 newtons over the mass, which is 25 kilos, to get the acceleration of 5.6 meters per second squared. And keep in mind, this acceleration is going in the negative x prime direction. So let's write our acceleration vector. And this is going in this kind of direction here. So as always, if you have any questions, put it down in the comment section.